This is Algebra 2 with Trig. We're working on Unit 8B.3a. We're going to talk about the unit circle today. One of the first things that we're going to do is flip our page over. We're going to take some sort of index card, sheet of paper, whatever you got, and we're trying to bring our paper down to the corner, and we want to line it up on the x-axis and line it up on the edge of your circle. So you hit this first dot, and we're going to make a mark right where that dot is and make a mark right where the origin is. Then you can use an ID card to connect those right together. So you have this small triangle that we now have that'll fit this exact circle. You can pause the video if I'm going too fast, but you can also come across, we're going to go to the second dot, slide this down, sit it on the x-axis, bring it to the second dot, take your time, line it up nicely so it gets there the best you can. Make a little tick mark at the second dot and a tick mark at the origin. Take your ID card or any straight edge that you've got and connect those together, and then use a pair of scissors so you can create a cutout like that. Now we're going to move those off to the side for later. We're going to flip our page back over and we're going to go from the top. Okay, we're going to be talking about the unit circle today. There are things that you are already familiar with. Okay? We're going to be talking about a unit circle, and the unit circle that we're going to be focusing on, which is true about every unit circle, is a zoomed in version of a circle with a radius of 1 on graph paper. That is the unit circle. It's 1 unit wide. The radius is 1. The coordinates that you already know about, if this is your origin, what is this coordinate going to be? The x value over is how many units? 1 unit. So it's 1 comma, how far up and down have we gone? 0. So it's 1 comma 0. And if this coordinate would be what? 0 right and left, and 1 up. And this coordinate would be what? -1, 0. And this coordinate? 0, -1. So you already know parts of the unit circle just through your previous knowledge. Other things when we learn about a unit circle, we're going to be talking about these 3 specific locations along the circle that make a triangle here, that make a triangle to the middle, and that make a triangle up to the top. 3 different locations. They all have a different x and a different y. Each one goes over a different amount, right? This is a small amount over, this is a medium amount over, and this is a bigger amount over. So they're all different x's and different y's to get to every one of those coordinates. You can tell that they're all less than 1. Because x1 is way over here to this line. None of those dots have a value of 1. So we're going to talk about those coordinates. Also, we're going to do them in every quadrant around our circle. So that's the unit circle. That's what we're going to talk about. We're going to talk about the angles that are created by those lines that meet those points. That's our unit circle. So the unit circle has an equation of x squared plus y squared equals 1. If you remember your equations about circles, this is a radius of 1 and a center of 0, 0. So it has a center of 0, 0, and it has a radius of 1. For these next 2 points that we're going to talk about, let me make my picture a little bit bigger so we can see it a little bit better. Okay, I have a center point. I'm going over to the edge. If I have this point that I'm going to head up to, I'm going to go over some amount and I'm going to go up some amount. And that's going to be my x value and my y value. Does that make sense? This coordinate would be x, comma, y to get to this location. Well, if this is an angle, theta, and this, of course, is over and straight up, so this is a right angle, we can use trigonometry to talk about what this value is and what that value is. If this is called the unit circle, then I know my radius, any radius on my circle, is 1. So this is considered the adjacent side of my right triangle, and this is called my opposite side of my right triangle. So what trig function would we use to discuss this adjacent side? Which trig function? We have trig functions called sine, cosine, and tangent. So if you think about the phrase SOHCAHTOA, which one is going to use the adjacent side? Cosine has an A. We'll get to this A here in a second, but cosine. Cosine is going to be adjacent over hypotenuse. Cosine of theta is going to be the adjacent side, which we would call the x value, because it's moving to the right. And the hypotenuse. What's the length of our hypotenuse? It's always going to be 1. So by multiplying 1 to the other side, what does x always equal? X is always the cosine of the angle. Okay? Let's take a look at the y value. The y value is always going to be the opposite over the hypotenuse. So which trig function do we use for that? Sine of theta equals the opposite over our hypotenuse. Our opposite side we're going to call the y value, so I'm not going to use OPP anymore. I'm going to use y. So how do we get y by itself? Multiply by 1. Well, that doesn't change anything. So what is the y value? It's always considered sine of the angle. That's kind of weird. That's kind of simple. So x coordinate of each point on the unit circle is what value? The x is always what value? Cosine of theta. The y coordinate is always what value? The sine. So if we think about tangent, what do you know about tangent? Tangent, remember, is opposite over adjacent. Tangent is the opposite side, which is your y value, over the adjacent side, which is your x value. Doesn't deal with the hypotenuse at all. It's opposite over adjacent. The y, the up and down, over the x, the right and left. the horizontal and the vertical. So tangent is always the opposite over adjacent. That's what we're most comfortable talking about, tangent. Which the opposite side we know was the y value, and the adjacent side we know was the x value. What was the y value? Sine. What is the x value? Cosine. So tangent is actually y over x, otherwise known as cosine theta, sine theta over cosine theta. So when we talk about a unit circle, we're going to be talking about different measurements. We're going to be talking about the 30-degree angles, the 45-degree angles, and any multiples of those. Okay, any multiples of those. Normal multiples to talk about would be 60 times 3 would be 90. And we could continue on and on. 120, 150, 180. Radian measures. We've recently talked about radian measures. What would be the equivalent radian measure of 30 degrees? We know that 30 goes into 180 6 times. So the 30 degrees is going to be considered pi over 6. Because pi is 180, we learned, and 30 goes into 186 times, so that angle would be considered a sixth of the whole pi. What would 45 be? Pi over 4. So 45 goes into 184 times, so that angle would be 1/4 of the 180, or 1/4 of the pi. What would 60 be? Pi over 3. Because 60 goes into 180 3 times. That angle is considered pi over 3. What's 90? Pi over 2. And we could just continue on. So those are the main angles we're going to talk about. And these are our radians of those degrees. We're going to talk about the coordinates that happen. Okay, and we'll evaluate. We'll figure out what is the sine. Let's talk about that right now. If we zoom back into this, sorry it's kind of small, I can zoom in some, but as soon as I put my calculator here, it's going to get large. Okay? What would you say is the cosine of 0 degrees? Well, what did I hear about that? I heard that cosine was the x value. And at 0 degrees, that's 1. So what do I think cosine of 0 degrees is? Any predictions out there? It's going to be 1. What do you think sine of 0 degrees is going to be? What is the y value at 0 degrees? What is the cosine going to be at 90 degrees? And what is the sine at 90? So we are already evaluating your sine and cosine at these particular values that are on the unit circle. What is the cosine at 180 degrees? Cosine, remember, is your x-coordinate. 180 is straight to the left. So I'm left 1 unit at 180. So I'm going to be -1. So that's called evaluating. Those are just simple ones. Okay, we're going to be working through all the quadrantal angles. That's what we just did. They were angles in standard position whose terminal side is on an axis. That was 90 degrees, 180, 270, 360. Those are called quadrantal angles. Quadrantal angles are always multiples of what degree? When we talked about up here, what angle is that? And what angle is that? And what angle is that? 90, 180, 270. Those are all multiples of what? All multiples of 90 degrees. Well, what radian would that be equivalent to? Pi over 2 is equivalent to 90 degrees. It's half of the pi. Pi was 180, and 90 is half of 180. So pi over 2 is pointing in the same direction. So we call that pi over 2 radian. What we're going to do now is take our triangle with the long leg and the short leg. We have a long and a short. Those are the legs of the triangle. I'm going to turn the page real quick just to give us a, wait, hang on. We're not going to do that. We're going to stay right here. We're going to talk about a 30, 60, 90 triangle. 30, 60, 90 triangle. There's a rule that you learned back in geometry class and even earlier in this class, that the short leg was some number, and the hypotenuse of a 30, 60, 90 triangle was twice the short leg. And the long leg was root 3 times the short leg. So if we have our unit circle, and we have a 30, 60, 90 triangle on our unit circle, the radius of the unit circle is what? What's the radius of our unit circle? 1. What part does my triangle represent for that? If we were to put our triangle on the unit circle, which part of this triangle might represent the radius? Would it be the long leg, the short leg, or the hypotenuse? The hypotenuse is always across from the 90 degrees. It's always across from the x and the y. The x and the y are perpendicular, so the hypotenuse is across from that. So the hypotenuse is 1. If the hypotenuse is 1, what's the short leg? the hypotenuse is supposed to be twice the short leg. So it's going to be half of the hypotenuse. So let's not use a decimal, let's use a half. And what's the long leg going to be? What's the rule? Take your short leg and do what to it? Multiply root 3 to it. So how do we multiply root 3 to this? It's going to be half root 3, otherwise known as root 3 over 2. When you multiply root 3 and a half, you multiply the root 3 to the top of the fraction. So it's root 3 divided by 2. So we're going to come over here to our little triangle. We'll write 1 for the radius. We'll write a half for our short leg. Leave room if you can. This was a 60-degree angle up here. The bigger angle is 60 degrees. The smaller angle is 30 degrees. What was our long side? Long leg. Root 3 over 2. And we'll talk about why that is. So can you flip that over now? And can you make those same comments on this side? What do you know? What did you just write on the other side? So now both sides of your triangle are exactly the same. Across from the 30 degrees is always a short leg. It's always going to be considered a half. Across from the 60-degree angle is a long leg, root 3 over 2. And the hypotenuse is always 1. We're going to do the same thing with the 45, 45, 90 triangle. There's a set of rules for a 45, 45, 90 triangle. Your legs are the same length. Because if your angles are the same, you have an isosceles triangle. So legs are the same. What's the relationship to the hypotenuse? X times root 2. So if you have the hypotenuse, it's going to be the leg times root 2. That's the formula that we could use. There are some formulas we could use over here, which we're able to talk about without going through them. But here, what is our radius going to be? On the unit circle, if we have a 45, 45, 90 triangle, what is our hypotenuse? On the unit circle. What's the radius on the unit circle? It's going to be 1. The radius on the unit circle is always the same. So if the hypotenuse is 1 and the leg lengths are x times root 2, how do I get x for the leg all by itself? What's the length of the x? We're going to divide by the square root of 2. 1 over the square root of 2. Now, we're not supposed to leave answers with a radical in the denominator. So what do we need to do? Rationalize. the denominator. Nice terminology. So we're going to multiply by root 2 over root 2. And what does that give us? What do you get when you multiply the top? What do you get when you multiply the bottom? You get root 2 over 2. Those are the two side lengths. So we're going to take our triangle that had equal sides. That was a 45, 45. It had a hypotenuse of 1, of course. It had a leg of root 2 over 2 and another leg of root 2 over 2. We can flip that over. And can you rewrite those on the other side? So now we have both of our triangles, which when we turn our page, we're going to be able to talk about how they can be placed on our triangle to identify what these coordinates are. Before we get to the coordinates, let's talk about the angles. What angles on this unit circle do we already know about?